So how will data be collected? So some clinical data can be you can observe it, you can download it, you can obtain it from a medical record. Um, for example, observations. Maybe an investigator is interested in the rate of hand washing and the differences between different class of providers. You can also download data from databases. You can obtain it. You can request permission. For example, if you wanted to go to the NBCRNA and get de-identified data on C-scores on sRNAs for a research study, you could request permission to obtain that data set, and you could conduct a research study on that. You can go through your electronic health records through whatever mechanisms, and you can either go in and each individual record, or maybe you have a database technician that's able to pull you the information you need. Certainly, we can collect information from subjects orally, where they answer questions, or they can, most commonly is they maybe fill out a baseline questionnaire with some demographic information, or even the instruments on paper with paper and pencil instruments. And then certainly these days with the internet, there's countless ways you can use the internet to help collect your data, especially with surveys, the most common tool being SurveyMonkey for easily conducting cross-sectional studies. Also, you can use biometric or physiologic instruments, not just paper and pencil, um, what we would call instruments. Also, we're sometimes referred to as questionnaires or even as scales, or some types of instruments that are used. But you can use tools that measure biological or physiological functions. So when selecting an instrument to measure study variables, you need to make sure it closely fits the conceptual definition of the variable. And here's a very important point, especially when you're reading an article. If you an article, and an investigator says that they developed a new questionnaire or instrument for that particular study to measure some phenomenon, and they don't go through the psychometric construction process, you need to question that um, and read that very closely, because development of psychometrically sound instruments can really take a long time, and they need to report or reference the reliability and validity results of any psychometric instruments used in a study. Sometimes this may just be as much as referencing the original article with just a citation number. Other times they may actually go in and provide a little bit more details. And this is this could be a whole 2 hour lecture in and of itself. And we're going to go over just the down and dirty of what you need to know in a couple of slides. But basically what you do is when you're developing an instrument to measure something, you go from a theory all the way down to a score, where you have this construct, which is kind of that abstract thing you're trying to look at that you can't really measure, and you develop that into a variable, and you can have what's called a measurement theory, which we'll talk about in a moment. And you're going through this theoretical development of it, and then you come down to operationalizing how you're going to actually measure it, and what unit of analysis, and even down to a score. So here's an example for depression. So a theoretical or conceptual definition would be the severity and depth of physical and psychological symptoms consistent with clinical depression as defined by the APA's DSM 4, and this was 1994. I think there's a more recent version out now. So the operational definition of this would be scores on the Beck Depression Inventory number 2. And even this particular instrument has an affective and a somatic subscale. All right, so what is classic measurement theory? And I will say I am by no means an expert on this, but I'm going to try and walk you through this, and I have provided you with some additional readings that provide you a little bit more information on this concept. But essentially what you have, you think about say a standardized test. So you have this observed score, which is really what you're trying to get is an individual's true ability, but then there's a certain degree of error involved with that. Um, and that error can be both random, which it just occurs, and then there can be some sort of a systematic error, which is what it can be most concerning. So if you look down here, is at this figure down here, notice that if we're just looking at random error, it doesn't affect the average or the mean. It only affects the variability around the average. So random error, what that may in turn affect is your standard deviation or your 95% confidence interval. Systematic error, on the other hand, can actually affect the average, and this can cause bias in a study. And so random error results from chance variations in the instrument. For example, maybe the directions are not clear. Maybe that subject on that particular day had a headache, or maybe the room was very hot that day when they're filling out the questionnaire on your study, and that lowers its reliability, meaning its consistency, that it's measuring what it's measuring the same thing over time. But systematic error results from some presence of some sort of extraneous factor that affects all measurements and can actually compromise the validity. So say an example, it would be a scale that's always reading 3 pounds too high. And so that's not a valid measurement of that person's true weight. So that can be a systematic error, because what we're really trying to do, so you can have a reliable but a not valid tool, so it's measuring the same thing consistently, but it's not the thing you're interested in. And then you can have something that's valid, but it's not reliable, meaning their scores are all over the place all the time. Every time you repeat it, it's not repeatably. You cannot reproduce it. And then you can have something that's neither one, or you can. What we're really shooting for is something that's both reliable and valid. So an aim of all reliability and validity measures is to eliminate or minimize as much of that error as possible. So what is reliability? Reliability is the degree to which an instrument produces consistent results, meaning it's measuring the same thing consistently over time when it's given repeated times. It's how stable, consistent, or accurate the instrument is. And reliability, there's 3 characteristics: stability, internal consistency, and equivalence of a measure. It's not a fixed property, and it certainly can rely on the population it is given to, the circumstances on how it is given, and the context or the conditions under which it's studied. Stability refers to how similar the results are when measured at 2 different times. This refers to consistency of measurement. It's stable. And a common reliability testing that's done with this is what's called test-retest method, where they're looking at the correlation between scores with, say, the same subjects on 2 different times. The statistical test that's used for this is called the intra-class correlation coefficient, and you can see the goal that's considered satisfactory there. The other one is intra I-N-T-R-A, rater reliability, and this is consistency between measurement by the same person, is another measure of stability. You're also going to look at is it equivalent, and this is the concordance degree of 2 or more observers regarding an instrument's scores. For one example, reliability test would be parallel forms reliability. And this is when 2 groups of people complete 2 different versions of the same instrument. Each version is trying to measure the same thing, and then what they do is the investigators examine the correlation between them. Or there's inter, I-N-T-E-R, rater reliability. And this is, for example, when you have 2 trained observers watching some sort of an event and they score it independently. This sometimes you see this in simulation research where you have investigators are grading, say, students going through a scenario, and then they compare their scores, and that's commonly reported with the Cohen's kappa, and you can see the values in terms of the strength of agreement. With you want to be upwards of 0.8 to 1 is your goal for a very good measure of agreement. Reliability also refers to internal consistency. Some instruments or questionnaires have multiple domains or subdomains that they're measuring, and so internal consistency evaluates if the domains of an instrument measure the same characteristic or construct, and the average correlation between all constructs items on an instrument, and that's reported with the Chromebox Alpha, and you can see the ranges listed there. So validity is whether a tool or instrument measures what it is supposed to measure. Now I've posted an article for you all to read on that these tables are taken from, that does a nice, it's a nice article that summarizes reliability and validity. So please take the opportunity to read through that. If you want to pause the video right now, you certainly can, and I'd like you to read through these different types of validity. So what you see here, if I go back, is we have the definition, gives you an example, and then a statistical test that may go along with it. And you can see most commonly many of these are using correlation tests here. And this is the article that I was referencing from Applications of Epidemiology. I found it when I was preparing for this lecture, and I think you'll find it. It's an easy read. It provides a nice overview of the topics.